Hi folks, welcome to 7.2, the Law of Cosine. So as a quick review, in 7.1 we talked about how some formulas that we know are for right triangles only, including SOHCAHTOA, the Pythagorean theorem, and then the area formula for a triangle, that 1/2 base times height. But what we're going to focus on in 7.1 and 7.2 is how we can extend those formulas so that they're actually work out for questions that involve all triangles and they don't have to be right triangles. And so now we're going to pick up with the law of cosines, and we'll do a few examples. We'll get a chance to practice some more law of sines and law of cosines, like decision making. How do you know when to use what? And then we're going to finish off with the area of a triangle. Two different formulas that'll help you in case you don't have the base and the altitude or the base and the height. Okay, so let's get started with the law of cosines. So, the law of cosines is actually an extension of the Pythagorean theorem. So let's imagine that we actually had a right triangle here. Okay, so let's say we had a right triangle, and we'll call this A, and this B, and this C. Actually, let me undo that. We'll go with C here and B here, okay? Now, if you had a right triangle, then you could call this A and this B and this C, and you could say that C squared equals A squared plus B squared. And that's something that we know. But what we're going to learn right now with our law of cosines is that we can actually have three sides of a triangle and still find out information of the angles, even if it's not a right triangle. So let's take our diagram for example for the law of cosines, and we're going to make it not a right triangle. We're going to make it an oblique triangle, okay, just like we had with our law of sines. And we're going to call this A, and we're going to call this C, and we're going to call this B, okay? And that still means that we have little a across from A, little b across from B, and little c across from C. Now, if you wanted to find C squared, okay, with a non-right triangle, you actually start with the Pythagorean theorem, A squared plus B squared. But then there's this part that we need that's going to take care of the fact that it's not a right triangle, and that's this part, minus 2AB cosine angle C, okay? So this second part right here, this takes care of the fact that it's a non-right triangle, okay? Now, when you learn about law of cosines in a textbook, they tend to give you three different versions of it, but they're really all just different variations of the same formula, okay? So, for example, if I start here and I have the C on this side, then it's going to be angle C at the end. So it's almost like a sandwich. Whatever side you start with is the angle that you finish with. So what that means is I could also say that this is A squared equals B squared plus C squared. So we take the other two sides, and then we're going to subtract 2BC cosine of angle A. All right, so again, whatever side is on the side by itself and the angle, those two kind of form a sandwich for the rest of the formula. And then the third variation is what if we're looking for B squared? So B squared will be the other two sides, A squared plus C squared, okay, minus 2 times A times C cosine B. And again, we have B here, and we have angle B over here, okay? So kind of like with our Pythagorean identities from the last chapter, as long as we can memorize one formula, we can kind of figure out the rest of them, and we don't have to memorize all of them, okay? So Let's jump into some examples and see what situations would we use law of cosines for. All right, so let's take a look at this first variation. We have a side angle side situation, okay? So let's draw a diagram for our triangle. We've got one side, another side, and a third side. We'll call this A, we'll call this B, we'll call this C, and I've got A is 15, B is 10, and angle C is 45 degrees. And I can see from here that I have a side, an angle, and a side. All right, a side, an angle, and a side. And the angle has to be between the two sides. And so what I'm going to do is I'm going to pretend like I didn't know that I was learning about law of cosines. And I'm going to set this up and see if I can use law of sines, okay? And that's one strategy I want us to think about, is that we should always start with law of sines because it's a little bit easier, and see if we can use that. So what happens if we try and use law of sines here? We get sine of A over 15 equals sine of B over 10 equals sine of 45 over C. So do I have a full pair? No, I do not. Do I have a full pair? No, I do not. Do I have a full pair? And that's supposed to say C on the bottom. Let's just fix that. So over little c. And here I do not have a full pair either. Okay, so if you don't recognize right away that it's a side angle side situation, you should try law of cosines, or law of sines rather, but you're going to find out you don't have enough information. And so because we don't have enough information, we're going to try our law of cosines. Now, I like to go ahead and find out whatever side is across from the angle that I'm given. So that in this case is going to be little c. All right, so little c squared is going to equal a squared plus b squared minus 2 times a times b times cosine of 45 degrees. Okay, so let's clean this up. 225 plus 100 minus 300 times root 2 over 2. Okay, well, I can reduce that. Those will reduce to 150. And then I've got 325 minus 150 root 2. Now, when I do these, I want to make sure I do the multiplication first, meaning that I gotta multiply that out, and then I can do that minus that, okay? So when I do that, I'm going to get c squared equals 112.868 ... Okay? And then I want to make sure that I take the square root, so I'll get my actual c value, not c squared. So when I take that square root, I get 10.624, and that represents the length of side C. Okay? So now once we've found side C, we can use law of sines to help us find angle A and angle B, because now we've got a full pair, okay? So just because it's alphabetical, I'm going to find angle A first. So I've got sine of A over 15 equals sine of 45 over the little c I just found, which was 10.624. All right, we cross multiply. 10.624 sine A equals 15 sine 45. And we divide. Sine A equals 15 sine 45 over 10.624. And we get sine A equals 0.9984. Okay. So when we go ahead and find this we do inverse sine, we'll get 86.721 degrees for our angle A. All right? Now, if we've got angle A and angle C, it's super easy for us to find angle B because we just do 180 minus angle A and angle C. So, angle B equals 180 degrees minus angle A minus angle C, which will give me 180 minus 86.721 degrees minus angle C, which is 45 degrees. And when I work that out, I will get angle B equal to 48.279 degrees. Okay? And so now I've got all three angles and all three sides, so I have successfully solved my right triangle. Or my non-right triangle, sorry. All right, so let's take a look at example 2. Example 2 showcases a different situation, right? In this case, I have a side, and I can tell that because I have one side, two sides, three sides, and I have no angles. So in this case, if we were to set up law of sines, we would get sine of A over 8 equals sine of B over 6, which equals sine of C over 7, and I don't have a full pair, I don't have a full pair, I don't have a full pair. So law of sines will not work. But we're going to go ahead and use law of cosines, and we're going to find the biggest angle, which is the angle across from the biggest side. So I've got A squared equals B squared plus C squared minus 2AB cosine, minus 2BC cosine A. And now I'm going to fill in my numbers. So 8 squared equals 6 squared plus plus 7 squared, let's say stay consistent, minus 2 times 6 times 7 cosine of angle A. So we'll get 64 equals 36 minus 49 minus 84 cosine A. So that equals 64 equals 85. Sorry, that's a plus. 85 minus 84 cosine A. All right, now our order of operations is actually the same as the last example, which means that I have to take this, move it to the other side, because I would have to do this multiplication before that subtraction. So I'm going to subtract the 85. I get negative 21 equals negative 84 cosine A. And so I'll get cosine A equals 21 over 84. And when I use the calculator to find that out, I will get angle A equals 75.522 degrees. Okay? Now this order of operations here is super, super important. I would say that's the number one place that students make mistakes, okay? So try really hard to make sure you're following those order of operations. Okay, so we can use law of sines to figure out a different angle. So I'm going to find angle C now, all right? So I've got sine C over 7 equals sine of 75.522 over 8. I cross multiply and I divide. I'm going to get sine C equals 0.847, which is going to give me angle C equals 57.910 degrees. All right. And then I'm going to go ahead and find angle B by subtracting A and C from 180, and I'll get 46.568 degrees. All right, folks, we're going to stop here. Come on back for part 2.